We've got an equation, x in terms of y here. First up, we're asked for dx by dy. So I need to differentiate between with respect to y. I'm going to call this one u and this one v. I've actually got the product rule going on. Dx by dy is going to be u prime v plus u v prime. Right, well, u prime is just going to be 1. Remember, we're differentiating with respect to y, whereas v prime, okay, I'm differentiating ln now, it's going to be 1 over ln, 1 over 2y minus 7, and then I will multiply by the derivative of the inside. So essentially, you differentiate ln as normal, it's 1 over x, in this case, or 1 over y, in this case, 1 over 2y minus 7, and then we are using the chain rule on this, so you differentiate by the, multiply by the derivative of 2y minus 7. Now, if you want a little bit more on where that came from, here I am to show you. So if I'm going to call this thing w. W is equal to ln 2y minus 7. And then I want dw by dy. And that is equal to, chain rule is dw by du by dy. I'm now going to call the 2y minus 7 u. So I actually have u is equal to 2y minus 7, and w is going to become ln u. I've done a substitution essentially. Now dw by du is just going to be 1 over u, and then du by dy is 2. And then I replace u by 2y minus 7. I hope this is making sense. And then I times by 2. I get exactly the same thing that I got before. This is kind of shows you why the chain rule works, because actually when I do it in full, that's what happens. Right, let's carry on. So u prime is 1, and then v is ln 2y minus 7. And then u is y plus 5. And I'm timesing by v prime, which was this actually is 2 over 2y minus 7. Just going to tidy it up. I think I'll write it as 2 bracket y plus 5 over 2y minus 7, and then the ln term second. Okay, good. B, we're asked to find the gradient of the curve where it crosses the y-axis. Two things. The gradient is dy by dx rather than dx by dy, but they are strongly related. They're just a reciprocal of one another. So dy by dx is 1 divided by dx by dy. So we can actually just find dx by dy and then do 1 over that. Brilliant. Now we're interested in where it crosses the y-axis, and that's along here somewhere. So it's when x is equal to 0. Okay. So when x is equal to 0, we're going to first of all have to set our function equal to that, or rather our equation, y plus 5 ln 2y minus 7 is going to equal 0. And this will give potentially two solutions when this bracket is 0, so y is equal to minus 5, or when this bracket is 0. I'll put a bit more working into this one, so when ln 2y minus 7 is equal to 0, i.e. when ln 1 is equal to 0, so it's when 2y minus 7 is equal to 1. Another way of thinking about it is you could raise both sides to the power e, and then it becomes 2y minus 7 equals e to the 0, which is 1, however, if you like it like that. So 2y is equal to 8, and y is equal to 4. Now, you've got to be careful here, because sometimes you get solutions that don't actually exist, and that actually goes for this one here. So if you were to carry on and get a possible solution for dy by dx, you would have to just check at the end whether it is actually valid. Probably best to do it at this point, so I'm going to talk about it now. Because when y is equal to 5, ln 2y minus 7 is actually negative. Reject, since And if you don't reject it, you will lose marks. So in fact, there's only actually one physical place where the graph goes through the y-axis, and that is when y is equal to 4. So when x is equal to 0 and y is equal to 4, dx by dy is going to be 2 times y plus 5, which becomes 9, divided by 2 times y, which is 8 minus 7, so just 1, I could just divide by 1, plus ln, now 2y plus 7 has kind of stayed in there, because that's when I did the product rule. So it's actually going to be ln of 1. It's gonna go. So we're going to get 18, in fact. And therefore dy by dx is going to be 1 over that, 1 over 18. Nice question.